everyone, welcome to another episode of the AOS-CX 10.16 release elevator pitch video series. I am Shobna, team at HPE Aruba Networking. In this video, I'll provide a brief overview of the new feature radius proxy support introduced in the 10.16 release. The radius proxy feature has been introduced to the AOS-CX switches to support role-based policy enforcement, or in other words called group-based policy or GBP. So with the 10.16 release, the radius proxy feature enables group-based policy enforcement even for clients that are not directly connected to the edge switches supporting VXLAN. So many networks employ L2 access switches connected downstream from these edge switches. And these L2 access switches often lack advanced capabilities like VXLAN and GBP. So with the AOS-CX 10.16 release, the CX switches now enforce GBP for clients on these extended L2 access switches by acting as a radius proxy. So the edge switches will act as a radius proxy for those L2 access switches to support group-based policy enforcement. So how does it achieve it? The edge switch acting as a radius proxy will forward the radius request received from the network access server at the access layer to the actual radius server, that is a home server, and also returns the responses received from the radius server to the access switch. So primarily the edge switch will act as the radius server for the access switch. So during this process, the edge switch will learn the radius responses received for the clients connected to the access switch, so that it will identify the roles assigned to the end clients and derive the group-based policy ID. So using this group-based policy tagging, it can enforce GBP for traffic that is coming over to the access switches. So the important criteria here is the network between the access switch and then the edge switch should be only L2. Both physical and lag interfaces are currently supported. So let's see the use cases and customer benefits. In terms of use cases, this feature is really boom for networks that deploy L2 access switches that do not support VXLAN and group-based policy enforcement, but still they need role-to-role segmentation. So this feature enables role-based access control for north-south and east-west traffic flows. So it supports clients connected to extended L2 access switches, including those from third-party vendors, allowing consistent policy enforcement even when these switches lack advanced features like VXLAN GBP. Customer benefits. Enhanced security. So this feature strengthens the network security by ensuring that policies are enforced for all end clients regardless of where they connect within the network. Operational simplification streamlines the deployment and management of secure policies, reducing the complexity across varied network environments. So this feature is supported in CX 6300, 6400 V2, 8100 and 8360. So let me explain how this feature works with a sample use case and associated configurations. So here is the sample use case. So I have a VXLAN environment. There are two VTUBs, VTUB 1 and VTUB 2, and I have an access switch connected to one of the VTUB. So those VTUBs I have renamed as leaf 1 and leaf 2. So this access switch doesn't support group-based policy. The group-based policy exists only in the leaf 1 switch. And have a user called faculty connected to the access switch and user called student connected to the leaf 2 switch. So I wanted to restrict the traffic that is coming from the user student to the faculty. Only SSH and ping has to be allowed. All other traffic has to be denied. So let's see how this can be achieved using the radius proxy feature, as this access switch doesn't support role-based policy or group-based policy. So the group-based policy exists only in the leaf 1 switch. So let me start explaining the configuration workflow here. So the bold highlighted configurations are newly introduced as part of this feature in this 10.16 release. The other configurations are pre-existing ones. So let's start with the access switch configuration. So before we go into the access switch configuration, you have to note down the IP address of the access and then the leaf 1 switch. So the access switch IP address is 99.3 and the leaf switch IP address is 99.1. Radius server IP address is 20.1.1.10. So in the access switch, we have configured the leaf switch IP address as the radius server. So the radius server host is pointing to the leaf switch. And then we have enabled the configuration for radius dynamic authorization. So when it comes to radius server, we support AAA, that is authentication, authorization, accounting. Apart from that, we do have support for dynamic authorization for the change of authorization feature. So both the radius server configurations point to the radius proxy switch, that is the leaf 1 switch IP address. And next is the normal authentication workflow, where you can enable your authentication methods like be it Autonex, MacAuth, or device profile. So I have used MacAuth here and have simply created the role called faculty, and I have enabled the Mac authentication in the client connected port. So that is simple configuration in the access switch. Next, we will see the configuration for the connectivity between the access switch and the edge switch, radius proxy switch. It's not like any access switch can act as a client for the radius proxy switch. It has to be onboarded securely. So for that purpose, we'll be using device profile to onboard the access switch in the radius proxy switch. Currently, we support only device profile. So it can be either over physical interface or lag interface. So in this configuration, I have used lag interface for securely onboarding the access switch. So let's see the device profile configuration from the radius proxy switch, that is the leaf 1. Here is the device profile configuration. So I have created device profile, extended device profile, and associated it with the role and LLDP group. So the LLDP group is for identifying access switches and then onboard them in the radius proxy switch. Only the switches that match the LLDP group will be onboarded in the radius proxy switch. So next configuration we have in the interface lag is auth mode, proxy mode. So this is the new CLI introduced. It can be either enabled in the interface level or in the role context. So this CLI states that the clients will be onboarded to the radius proxy switch as a proxy mode. So only then the traffic that is coming from the access switch will be subject to the GBP enforcement. Let's jump into the main radius proxy configuration. I would split it into three categories. First one is the global enablement of the radius proxy feature, radius proxy enable. So this CLI is really required, only then the feature functionality will work. Next is the radius proxy configuration for the AAA part, and last is the radius proxy configuration for the dynamic authorization. First, let's see the AAA part. For the AAA part, first we need to configure the external radius server. So the external radius server is 20.1.1.10. So I have configured the external radius server and associated it with the group called external radius server. So next is the client group configuration. For this radius proxy switch, the server is the external radius server and the client is the access switch. So we need to create the client group with the IP of the access switch, that is 99.3. So next in the radius profile configuration, we need to associate the server group and then the client group. The server group created is associated. Similarly, the client group is associated. And then we can also mention the IP that is used for the radius proxy functionality. It is the IP of the radius proxy switch. So let's see the dynamic authorization configuration. In terms of dynamic authorization, the external radius server is the client and then the access switch is the server. The reason being is the dynamic authorization requests are initiated by the external radius server to the access switch. Hence, it is reverse here. So the access switch is the server and the external radius server is the client. So let's do the configuration. So we need to enable the dynamic authorization client as external radius server and server as the access switch. Next, we need to associate those client group and then the server in the dynamic authorization profile. Similar to the AAA radius proxy profile, we need to mention the IP address used for the radius proxy communication. So this is the overall picture of the minimum configuration required for the radius proxy feature. Next is the GBP enforcement configuration. So where you configure the classes and then policy for the GBP and associate that in the role created for the client. Since I'm using the client called faculty, I've associated the created GBP policy and then VLAN for that role faculty. First, let's verify the configurations enabled. So you can use the show radius proxy profile and radius proxy profile statistics to view the configuration and then the statistics for number of access requests and accept sent and received. Next is the DIN authorization profile. To view the configuration, you can execute the show command show radius proxy DIN authorization profile and then profile statistics to view the dynamic authorization requests and responses. So let's see the client verification now. First, let's verify the client onboarding in the access switch. So you can use the pre-existing show command show port access clients and it will display the client onboarded along with the role assigned and then the authentication mode. The same client will be onboarded in the radius proxy switch as well. So you can use the existing show command show port access clients. It will display the two clients here. The first client is the access switch, so that has been onboarded using the device profile and associated with the role. So the flag here is set as device profile with mode as proxy mode. Next is the end client faculty onboarded in the VLAN 101 with flag set as radius proxy and mode as proxy mode. So this clearly shows the client has been onboarded using radius proxy feature. You can also use the new show command show radius glean clients to view the clients that have been gleaned because of this radius proxy feature. So it will display the MAC role and then the age of the end client and what are the flags like MAC auth, whether the gleaned info status is success and what is the role status, whether it is applied or not. So this comes to the end of this elevator pitch video. So for more details about this feature, refer the detailed TOA session which will be posted soon in the AREDS broadcasting channel. Thank you everyone. Bye.